Hey everyone, my name is Karen Heater, and I'm coming to you today from the Tree Ring Lab out of Columbia University's Lamont Doherty Earth Observatory in the United States. Now today I'm going to be giving you guys a video tutorial that my colleagues and I put together about how to measure latewood blue intensity from tree rings using the very popular software CooRecorder version 9.8.1. Now, this tutorial is geared towards you dendrochronologists that are just getting started with blue intensity. So we really hope that this is a useful starting point for you in your future endeavors with blue intensity methods. We hope you enjoy. Blue intensity, or BI, methods have become increasingly popular within the tree ring community over the last several decades. BI methods use visible light-based equipment, such as scanners or cameras with a dedicated software, to measure the amount of blue spectrum light that's absorbed across an annual growth ring. Now, BI measurements are closely related to physical wood density measurements, and as such, BI is a desirable parameter in dendrochronology, especially in dendroclimatology. Here, we provide a step-by-step tutorial on how to collect latewood blue intensity measurements using the very popular software CooRecorder, coupled with the software cDendro. In this tutorial, we will demonstrate how to perform the following tasks. Adjust the basic color intensity or CI settings to optimize BI measurements, generation of BI measurements, quality control your data following BI data generation, and save and export your BI data. This tutorial focuses on BI data creation. However, prior to BI data collection, you must properly prepare and measure ring widths of your wood samples. To learn how to delineate and measure rings in CooRecorder, use the provided link to watch the tutorial by Maxwell and Larson 2021. As you will see later in this tutorial, because of how BI data are generated in CooRecorder, you will need to take some additional considerations when delineating rings if you also intend to measure BI. BI values are measured across a frame, which is a defined area attached to the ring boundary points. You need to be sure that every frame is only capturing the image of xylem that you wish to measure BI from. Although our .pos file could be perfectly fine for only measuring ring width, generation of BI requires us to adhere to a few additional rules. Here are a few basic tips to guide you as you delineate rings for subsequent BI measurements. To demonstrate these tips, I'll next show you some good and not so good examples of ring boundary delineation for blue intensity measurements. First, we'll want to make sure that we delineate ring boundaries as close to the center of the core as possible. As you can see with the image on the left, the delineation path veers off to the right along the edge of the core. And while this is not overly problematic per se for collecting ring width data, when you go and collect the BI data afterwards, you will likely end up collecting unwanted BI measurements from the core edge or the core mount itself. Similarly, you can avoid accidentally collecting unwanted BI measurements from cracks by using the crack marking tool. Finally, try to delineate around problem areas where you have any anatomical or discoloration issues. For example, the presence of resin ducts is very common in northern hemispheric conifers. So in this example, I simply moved my delineation path to avoid the resin ducts present in the latewood portion of the ring. We're ready to begin. Let's say we've already delineated rings in CooRecorder. To open the coordinate file from which we will collect our BI data, click File, and then select Open Coordinate File. Then select the .pos file you would like to open and click Open. CooRecorder has several data picking modes. Click on the lower left-hand corner of the screen to see which data mode you are in. The second one, the Measure Ring Widths or Generate Blue Data, should be the default option. If necessary, reselect this option and click OK. Here we have an image of the sample with all the markers of annual ring boundaries as well as the season wood. So our file is now ready to generate BI data. Now we will define where and how the BI data are generated. Navigate to and click on the CI Measurements option on the taskbar at the top of the window. From the drop-down window, select the first option, Settings for Color Intensity Measurements and Calibration. Well, here we have a rather intimidating window with plenty of options and settings, but don't worry. For now, we'll just focus on the essential parts only. If this is your first time opening the CI settings in CooRecorder, the majority of the window will not be active. First, ensure the box in the upper left corner labeled Enable Color Intensity Measurements is checked. Then, to activate the collector window, ensure the box labeled Enable this CI collector is also checked. We can split the window into 5 major sections. First, on the far right, we have a diagram that helps visualize what each CI setting is referring to. In the top left section, we can select if we want to generate color intensity data and how many measurements we want to perform during one run. In the middle right section, we can select what part of the visual spectrum we want to use, what part of the ring we want to measure, and the way the data image will be processed. In the middle left section, we can select the location, size, and shape of the data collection frame. And then on the bottom left, we can name and save the measurements. Starting from the top left side of the window, skip down to the third box and make sure that the box labeled Show Where Data is Picked to Create CI Data is checked. This will allow us to visually inspect the BI data on the core after it is collected. Next, go down to the Select CI Collector section. Each CI collector allows users to create a unique set of CI measurements. Notice that there are multiple collectors, meaning that users can produce multiple measurements at once. For example, if I wanted to collect both early wood and late wood blue intensity, I would use collector 1 to produce early wood blue intensity measurements and collector 2 to produce late wood blue intensity measurements. Now today, since we are only measuring late wood blue intensity, we will just use the one collector. Below the bubble for collector 1, ensure that the box checked Enable this CI collector is in fact checked. And checking this box gives you the ability to edit the remainder of the window. Below, you also have the option to write a comment about the collector settings. Personally, I always like to put the species that I'm working with for this particular BI collection. Moving to the right of the comment box, we have the data creation options. Under the first set of data creation options, you can select which color channel you would like to collect. For blue intensity, we will select the blue channel. Next, below the color channel, you can choose the wood type for data creation. In this tutorial, we will cover the most common option, collecting BI data from the late wood portion, so we will click the first bubble labeled late wood. However, you can apply the same procedures that we will cover in this tutorial for collecting early wood BI as well as delta BI. Below, you can then choose how you select your data with the two options, mean of sorted pixels or mean of slices. We will use mean of sorted pixels. Next, we will work through multiple parameter settings and show you what changing each setting does to the BI data. In order to see this, check the box in the lower right-hand corner labeled Show CI Spectra for all rings. While still under the data creation section, we can first adjust the percentage of light or dark wood we are using to collect the BI data. This value ranges from 0 to 100. Here, the default is set to 30%. To change this percentage, type the desired percent as a value from 0 to 100 in the text box. Say we want to use 5%. We will simply type 5 in the box. In doing this, we are now collecting information from the 5% darkest pixels in the late wood. Click the Recalculate button to see how the data are changed. Now we'll take a few moments to scroll over the core to visualize the changes we just made. These are the BI measurements with the original percentage set to 30%. And now we have the BI measurements where the percentage is now set to only 5%. Below the percentage of light or dark wood box, the next option in the data creation section is to select whether the color data are collected from the dark side or the light side. By default, the box is checked to collect data from the dark side, which is especially important for latewood BI. If you wish to collect from the light side, simply uncheck this box. Moving to the left side of the window, there are multiple settings that can be adjusted under the Frame Specifications section. These settings will change the geometry of the data collection frame. The first setting is Frame Width, or W. The default is set to 100 pixels. To change the width, type in the new value you would like in the text box. Note that if the frame width is set too high, you may end up collecting color intensity data from the core and the core mount. To demonstrate where this may be problematic, we will set the width to 400. You can also adjust the frame width limiting factor. This limits how wide the frame will be compared to the ring width. Especially if you have narrow rings, adjusting this value will help ensure that you don't unintentionally collect latewood BI data from undesired areas. The default is set to 3, meaning that the frame width will never be wider than 3 times the ring width. Here we have an example of where the frame width limiting factor is set to the default of 3. Now notice the difference in how much wider the collection frame is for the wider rings compared to the narrow ones. To further demonstrate the effects of changing this setting, I will now change my frame width limiting factor to 5. Now instead of using a larger frame width limiting factor, we'll use a smaller one. We'll go back to the CI settings and change the limiting factor to 1. Especially for narrow rings, it's important to recognize that setting the frame width limiting factor to a smaller value like 1 really limits the area from which the BI measurements are collected. For the rest of this tutorial, I will change the frame width limiting factor back to the default of 3. Next, you can also adjust the position of the frame relative to the position of the latewood border points, or F. When measuring latewood BI, we recommend using a positive F value, meaning that the frame overlaps the ring boundary and starts in the early wood in front of the latewood border. You then can adjust the maximum frame deepness, or D. The default is set to 200. For this example, we will set a new depth of 20. We will now take a few moments to compare what changing the depth of 200 to 20 looks like. So notice when we change the depth from the default of 200 to a smaller value such as 20, especially for wide rings where the latewood width is also wide, we now aren't encompassing all of the latewood portion of the ring with our CI collection frame. Lastly, for frame geometry settings, you can adjust the frame's relative margin to the next ring boundary, or K. This ensures that even if you are using a high frame depth value such as, say, 500, the frame will never touch the next ring. A value of between 0.2 and 0.3 typically is sufficient, but this can be adjusted as needed. In addition to changing frame geometry settings, delineating the season wood points also helps to keep our BI data collection frame within the latewood portion only. As you can see, there are numerous parameters controlling the right size and location of the data collection frame, because we want to extract blue intensity data values from a deliberate, defined portion of the annual ring. Now, all color intensity, or in this case blue intensity data, are stored as what's called a .wid file. Below, under the select.wid color CI output files section, you will have options of the output files that you would like to produce. By checking the first option, we will produce the inverted blue reflectance values, otherwise known as latewood blue intensity. Once settings are defined here, we can close the settings window. Now that you know how to make settings adjustments for data collection, we can apply the BI measurements. Navigate to the blue and white LB button on the main taskbar. When you click on this button, a window will appear with all collector options. First, check the box labeled Show where data is picked to create CI data. This will allow you to actually visualize where the color intensity data are being collected from and can help with quality checking. Our BI data are generated using the mean of sorted pixels. This option is easy to visualize, so we recommend using this option, especially when you are first getting started with BI methods. You can view data for one collector at a time. To view the latewood blue intensity data based on collector 1 settings that we just finished adjusting, click the bubble for collector 1. Once collector 1 is selected, simply click OK to exit this window. Once the BI data are generated, in CooRecorder 9.8.1, a pop-up window will appear letting you know what data you are looking at. To exit out of this window, simply click OK. You should now see BI measurements in the latewood for your entire core. Once BI data are generated, we recommend that you go over your core ring by ring to visually evaluate the way the BI measurements were collected. This step is critical and will lead us into the next part of the video tutorial. We just collected latewood blue intensity data for each annual ring. Now, in a perfect world, this would be the final step before we save the measurements. However, many things can go wrong during the data collection process, then potentially negatively affecting your resulting BI data. To correct possible errors, change the location of ring boundary points, change the features of the color intensity data collector frames, and remember to use the crack marker tool when necessary. Remember to generate BI data again after making changes and repeat the visual inspection across the entire core. This is very important because changes in data collection frame features are applied to all of the rings, the one you want to correct, and all others. Thus, some unintended changes could appear in parts of the core that were previously considered to be okay. Here we see a common example of where the frame width is set to too high of a value, and we accidentally are collecting BI data from undesirable areas, such as the edge of the core or the core mount itself. To fix this example, I'll go back to my CI settings and readjust my frame width from 400 back to 100 pixels. Well, that looks much better. So we solved this problem by adjusting the frame width, but note that this is not the only solution. I could also go back and shift my original ring boundary points to be further away from the edge of the core. I could also try adjusting the frame width limiting factor. Importantly, we would like you to know that there is never a one-size-fits-all solution. Rather, we recommend using a combination of strategies when quality checking your data. Once you are satisfied with the BI data collection for your core image, navigate back to the blue and white LB button on the main taskbar. At the bottom of this window, there is a box you will check that says Run All Enabled CI Collectors. Check this box and click OK. This will save all data from all enabled CI collectors in the same file directory as where the coordinate, or POS, and image files are saved. The color intensity data are stored as .wid files with really long file names. Here we show you the naming convention of the files. As you can see, the color intensity measurement file name tells you a lot of information about how and where the measurements were collected. Now that our latewood blue measurement data are saved, we want to export our latewood blue measurement file to be in a more common format, such as a .rwl file. We will do this using cdendro. Click on the cdendro icon on the main toolbar to open the program. To open your measurement file, go to Samples on the top toolbar, and then select the second option from the drop-down window that says Open one or more single sample files. Select the .wid file, and then click OK. Once the .wid file is loaded, go back to Samples on the top toolbar and select the option Save Ring Widths in .rwl decadal format from the drop-down menu. The RWL file you will create will be saved in the same file location as all other .pos, .wid, and image files we worked with in this tutorial. Go ahead and click Save. Now, enter the sample ID by typing it into the text box. I will use COO001, then click OK. Now we will navigate to the .rwl file we just created to ensure that our data were exported correctly into decadal format. Looks good! For a more detailed reference on cdendro, see the video tutorial by Maxwell et al. 2021. There is much more you can learn about working with blue intensity. From this starting point, we recommend examining various combinations of data collector settings and options, and also reading the excellent tips provided by the creators of CooRecorder. This concludes our BI CooRecorder tutorial. You have now seen all the steps needed to generate, verify, and save BI data. Congratulations! You have your first blue intensity measurements. We hope you enjoyed this tutorial.